Hello everyone and welcome back to the channel where we dive into the world of software development, one fascinating concept at a time. Today we are embarking on a journey through the evolution of software architecture, from the foundational layered architecture through hexagonal and onion architecture, all the way to the increasingly popular clean architecture. Have you ever wondered how these architectural patterns came to be, or why do some designs suit certain applications better than others? And as Jamie, my colleague, said, it depends. No one architecture fits all. By the end of this video, you'll have a clear understanding of these styles, their historical progression, key principles, and practical applications. So whether you are new to software architecture or a seasoned developer looking for a refresher, stick around. This one's for you. Layered architecture, the starting point. Let's begin with the classic layered architecture, also known as n-tiered architecture. This design separates a system into distinct layers, commonly the presentation layer, business logic layer, and a data access layer, with each layer have a specific responsibility. The key feature of this approach is its simplicity. It's easy to understand, implement, and use as a starting point for many projects. The data access layer, however, sits at the center of the architecture, creating a top-down dependency. The presentation layer depends on the business logic layer. The business logic layer depends on the data access layer. The data access layer remains isolated, oblivious to the layers above. This tight coupling, while functional, possesses challenges. Each layer is highly dependent on the one below it, making the system rigid and harder to escalate or modify. Over time, architects sought to address these limitations. In the next iteration of our architecture, we should prioritize shifting the dependency from data access to the business logic layer. By establishing the business logic layer as the central point, we can make the domain the focal point of all future architectural design. This strategic change ensures that layers evolve around it, enhancing overall cohesion and effectiveness. You may be wondering how we can achieve this transformation. One effective approach is to implement interfaces. For example, an iRepository interface in the core can have concrete implementation in the data access layer. Similarly, an email service interface can have its implementation in any external service. This design ensures that the core logic remains independent of frameworks, database, or APIs. The application interface with external systems via well-defined interfaces, making it easy to swap dependency without disturbing the core. The business logic becomes the core of the architecture, surrounding by ports, interfaces, and adapters. The ports act as boundaries, allowing the core to interact with the outside world without being tightly coupled to a specific implementation. This development ultimately resulted in the adoption of hexagonal architecture. Hexagonal architecture, breaking free from coupling. Hexagonal architecture, also known as port and adapters pattern. This approach shifts the central focus from data access to the business logic, aiming to make system more adaptable and easier to test. The structure is often visualized with primary or driving adapters on the left. For example, user interfaces like CLI or API initiating requests. Secondary or driven adapters on the right. For example, third-party systems like databases or email services. Application core is in the center, processing requests and directing flow. The process begins at the left with the primary or driving layer, where the request originates. It seamlessly moves into the application core, which is central to our business logic. Within this core, our business application interacts with various ports to execute the request. For example, it might engage with an iEmail or iSMS service. Each of these services is connected to an adapter, which provides the implementation of the respective interface or port. These adapters, situated in the secondary or driven layer, offer the necessary service implementation. Once the process is complete, the results are sent back to the application core, which ultimately delivers the requested outcome to the client. Onion architecture. A step further. Building on hexagonal principles, onion architecture emphasizes the business core even further, arranging the system in concrete cycles. Domain models and business rules reside at the center. Surrounding layers handle application services and infrastructure. Dependency inversion is key here. Outer layers depends on inner layers, never the reverse. This ensures that business logic and domain models remain unaffected by changes in user interface or external systems. A notable advantage is its testability and flexibility, which align perfectly with agile practices. For example, at the center, you might have domain models and services. The outermost layers, like UI or infrastructure, act as interface to the outside world. I can represent these layers in a circular format. On the left, we have the UI, and on the right, we have the infrastructure. As you can see, I can adjust the design to be circular, like this. Clean architecture, the best of all worlds. Finally, we arrived at clean architecture, which takes the best aspects of its predecessor while simplifying certain layers. The business rules remain central, encompassing all domain logic. The layers are organized to emphasize use cases, highlighting what system does rather than how it achieves it. Therefore, we do not have a separate layer for domain services. Instead, it has been integrated into the domain layer. Additionally, business rules such as implementation of CQRS and commands are located in the application layer. The web UI layer also functions as a dependency injection system, dynamically determining which implementations to use for interfaces such as iEmail. This means we can have multiple implementations for a single interface, but it is the UI's responsibility to decide which one should be injected. A distinguishing feature is its focus on maintaining independence from frameworks and external tools. This makes the software resilient to change, highly maintainable, and easy to extend. Let's explore the transition from hexagonal to clean architecture in simpler way. The simplest way to represent hexagonal architecture includes the user interface on the left and the infrastructure on the right. The journey begins at the user interface, which is known as primary or driving layer. This could involve an HTTP request and a web server to handle that request. It might also take the form of a command line interface, CLI. On the right side, we have various providers that functions as adapters. Example of these providers includes search engine and SMS server and mail server, among others. In this slide, we have a clearer view of the primary driving adapters and secondary driven adapters. For example, when an HTTP request is received, it can come through a controller or a console command. Our application core then begins processing that request. During this process, it may call on different ports. For instance, it might send a notification, for which we have two implementations, an SMS adapter and an email adapter. Additionally, it may use a search adapter to perform a search operation, and ultimately it will return the results to the user. Now it's time for onion architecture. This approach begins with layering the application code to enhance maintainability. Following this, we developed a clean architecture which represent a slightly improvement in making the applications more maintainable, as we have discussed in previous slides. There is a popular architecture known as vertical slice architecture that I will discuss in my upcoming videos. To summarize the journey, layer architecture introduced clear separation of concern but suffered from tightly coupling and rigidity. Hexagonal architecture addressed this issue by decoupling business logic from external dependencies via ports and adapters. Onion architecture took this a step further, emphasizing the domain models and dependency inversion. Clear architecture refined these ideas, focusing on simplicity and aligning design with use cases. Each style represents a step forward in building robust, scalable, and adaptable systems. That wraps up our deep dive into software architecture, from the foundational layers to the elegant design of clean architecture. We have traced how these patterns evolved and adapted over time. Hopefully, you'll gain insights that will inspire your next project. If you enjoyed this video, please do like, subscribe, and share your thoughts in the comments below. Thanks for watching, and I'll see you in the next one.